What if I told you that AI models like GPT could be trained not on words, but on numbers, sequences, or even music? That's exactly what a recent Reddit thread from r/machine learning is exploring. This is not just a theoretical idea, it's a real experiment being conducted by researchers. By training GPT-like models on non-language series like stock prices, weather patterns, or even protein sequences, AI could gain the ability to understand and predict complex numerical relationships. Imagine a model that doesn't just generate text, but forecasts economic trends or solves physics problems. This is a huge shift in how we think about AI and its applications. The implications are staggering. From healthcare to finance, this could change everything. Let's dive into what's happening in this exciting new field of AI research. Traditional AI models like GPT are trained on vast amounts of text data, which allows them to understand and generate human-like language. But what if the data we want to analyze isn't text at all? That's where the concept of training GPT-like models on non-language series comes in. These models are designed to process data that doesn't follow the structure of language, like numbers, time series, or other structured sequences. This is particularly useful in fields like finance, where stock prices are analyzed over time, or in physics, where researchers need to predict complex systems. The challenge lies in adapting the model's architecture and training process to work with non-textual data. But the potential rewards are enormous. By doing this, AI could become more versatile, capable of handling a wider range of tasks without relying on text. This is a major step forward in AI research. So how exactly do you train a GPT-like model on non-language data? The process is similar to traditional training, but with a few key differences. Instead of text, the model is fed numerical sequences, like stock prices, sensor readings, or even DNA sequences. These sequences are then processed by the model using techniques like attention mechanisms and transformer architectures, just like in language models. Model learns to predict the next value in the sequence based on previous patterns, much like how GPT predicts the next word in a sentence. This requires adapting the input format and training objectives to focus on numerical relationships rather than linguistic ones. Researchers have found that by using similar techniques, models can be trained to understand complex patterns in non-textual data. This opens up a whole new set of possibilities for AI. From predictive analytics to scientific discovery, let's look at some real-world examples of how training GPT-like models on non-language data is being applied. In finance, models are being trained on historical stock data to predict future market trends. In healthcare, researchers are using similar techniques to analyze patient data over time and predict disease progression. In physics, models are being trained on particle collision data to help scientists make new discoveries. These models are not just theoretical, they are being used in production environments to make real decisions. For instance, a model trained on weather data could predict extreme weather events with high accuracy, helping cities prepare for disasters. Another example is in engineering, where models trained on sensor data can predict equipment failures before they occur. These are just a few of the many applications that are emerging from this new approach to AI training. The possibilities are truly endless. When comparing traditional language models like GPT with models trained on non-language data, the key difference lies in the type of data they process. Language models are designed to understand and generate text, while non-language models are built to analyze numerical or structured sequences. This means that a GPT model trained on text can write essays, answer questions, and generate code. But it can't predict stock prices or model physical systems. On the other hand, a non-language model can predict future values in a time series, but it can't generate coherent text. The two approaches have different strengths and weaknesses. However, researchers are now exploring ways to combine both approaches, creating hybrid models that can handle both text and numerical data. This could lead to a new generation of AI that is more versatile and capable of solving a wider range of problems. The implications of training GPT-like models on non-language data are huge. This approach could revolutionize fields like finance, healthcare, and physics by enabling AI to make more accurate predictions and solve complex problems. It could also lead to the development of new AI tools that are more specialized and efficient. For example, a model trained on financial data could be used to make investment decisions, while a model trained on medical data could be used to diagnose diseases. This could reduce the need for human experts in certain areas and make AI more accessible to people who don't have the technical skills to use traditional AI tools. Additionally, this approach could help AI models become more interpretable, as they are trained on structured data that can be analyzed more easily. This is an exciting time for AI research, and the potential applications are only beginning to be explored. If you're interested in training your own GPT-like model on non-language data, here's a quick tutorial to get you started. First, you'll need a dataset of numerical or sequential data, like stock prices, weather data, or sensor readings. Next, you'll need to preprocess the data to make it suitable for training. This usually involves normalizing the data and converting it into a format that the model can understand. Once the data is ready, you can use a transformer-based architecture, like the ones used in GPT models, and train it on your dataset. You'll need to adjust the training objectives to focus on predicting the next value in the sequence rather than the next word in a sentence. Finally, you can test your model to see if it can make accurate predictions on new data. This is a simplified overview, but it gives you a good starting point for experimenting with non-language AI training. In conclusion, training GPT-like models on non-language data is a major breakthrough in AI research. It opens up new possibilities for AI applications in fields like finance, healthcare, and physics. This approach allows AI to understand and predict complex numerical relationships, making it more versatile and capable of solving a wide range of problems. As researchers continue to explore this area, we can expect to see even more exciting developments in AI. Whether you're a researcher, a developer, or just a curious viewer, this is an important trend to watch. If you found this video interesting, be sure to subscribe for more AI news and updates. The future of AI is here, and it's more exciting than ever.